Hello and welcome to another episode of Get to Know the Speakers of Digital Conflicts. Today we have with us Viktor Sobol, who is staff software engineer at Agoda, Booking Holdings. He will be speaking on the topic Cloud Native Technologies and Containerization, What to Know, during the Information Technology Conflicts happening in Delhi, India on 22nd September 2023. Hi Victor, welcome to the chat show.
Hi, Ankit. Thanks for having me. It's my pleasure to join the show.
Well, it is our pleasure to have you on board also. So, Victor, please give us a brief introduction of yourself and your field of expertise for the audience.
So I'm Viktor from Ukraine. Most my expertise and day-to-day work lies in MLOps field. Saying in more concrete terms, it's like using Kubernetes workloads and cloud native technologies to orchestrate data and machine learning training pipelines. So the difference with classic Kubernetes workloads, which are usually kind of like endlessly running web servers, is with some number of replicas, is that data and machine learning workloads, the first thing, they have finite lifetime, and the second, they might have huge spikes in resource consumption. So you loaded a lot of data, your model needs a lot of processing power, and there comes challenges how to manage resources. So you actually cluster stays utilized, and people get their fair share. So that's one of the example of challenges we have in MLOps field. Yeah, so that's about me.
Okay, that was good to hear. So, are you excited for this particular event?
Yes, of course. I'm extremely excited. So at first, the list of speakers gives a huge promise about the quality of presentation, and I'm keen to meet attendees, like people who have the same technical interests as I do. And besides the conference itself, it will be my first time visiting India. So I'm expecting a lot of new impressions from my travel ahead.
That's very nice. I have a few questions for you today. So, shall we begin with the first question?
Yes, let's do it.
So, can you explain how has your experience been with the K8s?
Sure. So yeah, I'm a big fan of Kubernetes technology. That's first of all the huge thing and awesome piece of engineering. So and like at my work, yeah, I observed that it's efficient, it facilitates different environments for different application types, like classic observers, data, some machine learning workloads. Another cool thing that it's, indeed cloud agnostic. So of course, there is still difference between managed Kubernetes services provided by different cloud vendors, but the gap gets narrowed down. But the idea that you work at one organization, you work at another, more or less we have a standard in industry how we run our workloads, and it not only gives you the faster onboarding time to a new company, to a new team, the processes of running efficiently, reliably workloads getting shared between organizations, so it hugely benefits the whole industry. Another thing is extensibility of Kubernetes. So kind of like discovering, I'm still kind of time to time discovering new extension points of Kubernetes itself. It's like new world wonders. And I'm pretty fascinated that you can extend basically everything there, right? So that's huge technology by itself, but as well, you can plug in a lot of stuff related to your organization, related to your business logic into Kubernetes. You can, related to your workload types, you can change how the pod gets scheduled, what's the definition it would have when it runs, like introduce some operators, CRDs. And the cool thing, amazing thing about it, that it's all comes by design. So people, while they were designing Kubernetes as a technology, they thought about extensibility in the first place as a first-class citizen, and it gives a tremendous advantage. And so another thing which I can talk about, which saves me a lot of time and saves other people, operators, a lot of time, is self-healing properties. It's like auto restarts, replication, basically those abstractions which ensure reliability ensure uptime for application. Those abstractions take a lot of manual work from administrators, operators, users, which again saves time, saves money for the organization, reduces the human factor error. So only benefits. Of course, there are some caveats, and again, they come in particular logic of application. When you scale up, scale down, there's always some risk, but of course, running it successfully requires some knowledge. Another thing is scaling, which I just mentioned, that if you design your application a certain way, you can be more or less sure that no matter what peak loads you would have, your service would scale up to demand and then scale back. And again, it's kind of outsourced manual work from the administrators. And another caveat that Kubernetes itself, yes, it's huge and complex technology. Not everyone requires to run it. Not everyone has a problem which it solves. Of course, from like engineering point of view, yeah, everyone would like to play it, would like to understand it better. But from organizational point of view, from process point of view, not every organization needs it. So I guess that should summarize my experience. All told, I'm pretty amazed by it.
Okay. So how it's like running big data tools and other non-typical web workloads on the KAs?
Yeah. So again, my day-to-day job mostly about not like typical web services, but big data stuff and machine learning pipelines, with the difference which I outlined in the beginning. Again, like because of the extensibility, Kubernetes allows you to do it seamlessly, to do it like in automated fashion, but requires additional knowledge about the big data itself. So if you take Apache Spark into example, Apache Spark is a tool which allows you to process like huge volumes of data, to run those processing in parallel. And they do support integration with Kubernetes. And usually, before at least, like running Apache Spark would require you to set up like a Hadoop cluster to manage it separately. But now once you have Kubernetes cluster for some type of workloads, let's say for web workloads, you seamlessly can come and run your big data workloads in the same cluster. Whether it's good or bad to have one computational cluster for both type of workloads, that's other question. It's again comes with organizational question, how we make sure that we're having everything reliable, but you can do it. You don't need like separate cluster, you don't need separate expertise, you don't need separate team for it. Yeah, and this definition, this ability to run like different type of workloads, like specified type of workloads, comes from extension points like CRD, customer resource definition, and operator. Kubernetes allows you to define certain operators which know how to run particular workloads, basically automating certain things which before required like the whole team to manage, like, let's say, Hadoop cluster. Now you can like write some operator and run your Spark with this operator. And operator allows you to encode application domain knowledge, that like how to spin up executors, how to spin up driver, how to control it, how to clean up resources, etc., etc. And it's very well suited for non-traditional, certain non-traditional, non-typical workloads. Again, auto-scaling comes here with a huge benefit, because maybe you run the job which processes the data, let's say from yesterday, day before, right? And in certain days, your business might have a lot of data. The next day, due to some events, the data volume is not that huge. And what you want to spin up that amount of resources to handle the workload of data. Spark allows you to do the dynamic configuration. Kubernetes allows you to do this like auto-scaling. Both of them have integration, and you seamlessly can just write one code. And don't, as developer of this job, don't think much whether how much resources do I need. You know that both of them would agree on the certain resource demand, which would be just enough for the job processing. Everything after it will be just deleted because it's not needed. And again, it saves like tremendous amount of money for the organization. Yeah, so I guess again, like super happy, requires some expertise to, again, in both fields, in let's say how Spark works, how does data gets transferred. Of course, we cannot just like dump huge file into some node on Kubernetes. It of course requires some data warehouse, data lake to store data, to store intermediate results. But Kubernetes automate a lot of things, which helps a lot of organizations. So you need smaller teams or teams which can handle like different clusters for the whole organization. That might be it for this question, I think.
All right. So by the looks of it, it looks like that K8s has been helping a lot of companies, with the data management and all the other, day-to-day things that.
Yeah, indeed. Like it started at first maybe from like people start using it just to automate maybe deployment of web services, and then it came to another fields like to data processing fields, and have a huge benefit. I'm not sure if you compare, let's say, cost saving from, let's say, classic backend application and maybe to data application, maybe cost saving from running data application even more than just like proper orchestration of backend applications.
Okay. So, basically what's it like the debugging experience with the K8s?
Yeah, so this like recently, fairly recently, in 1.25th version, one feature was introduced called ephemeral containers, and that thing actually helped with debugging like tremendously. Now you can like you have a running pod, this pod has main container, and usually like your running container, the image for this running container should not have much of the debugging tools, let's say, to analyze network packets or like some other things from like security reason, from image management reason, etc. But let's say you know that, let's say you try to debug Spark driver and you don't know why it cannot communicate with the executors. If you need to do this network debugging, you would need to maybe to update your image, to resubmit the Spark job. But with this new feature of ephemeral containers, you can have your debug image, special image, which already has all the debugging tools. Into your running pod, you can attach another container, basically update one, add a container, which would share all the space, like process space, file space, network space, with the main container. And then you have access basically to everything what happens inside your main container, but with all the tools you have in your like custom debugging image. And with this approach, you can like solve issues really, really fast. Like, whatever you need, you have your predefined, and everyone should have the predefined like scripts, which helps to narrow the issue. Yeah, and I'm kind of like still amazed. It's I guess a year plus of this feature, and I'm still amazed that it like helps me in my day-to-day life. Besides it, yeah, Kubernetes has extensive APIs like using kubectl. You can get information about pretty much any abstraction which Kubernetes has. The trick here is that you must know about those abstractions. So again, like the good debugging experience requires you to have good understanding. So once you have good understanding of what you actually want to debug, then yeah, and Kube API would allow you to see everything what you want. Maybe the main challenge comes with especially running like big data workloads or like any other like workloads which require special operator, because in this case, you need to understand the logic inside the operator, check CRDs, check the actual workload, and like, you need to jump between different spaces to understand what is going on. But again, that's ideally should be a rare cases when you try to understand what's wrong. That's it, I guess.
All right, Victor. So thank you so much for answering these questions for us today. And thank you so much again for your appearance for the show today. And I really hope that the audience will relish the points that you just shared with us. So would you like to add a few words for the audience that are going to be joining this conference?
Sure. Yeah. So definitely look forward to meet everyone in person. Yeah, look forward to learn new things. Because again, like speakers promising to share great knowledge, and hopefully I can teach someone a few things too. So yeah. So look forward to meet everyone during the event, and you personally, Ankit.
Yes, we also are looking forward to meeting you and hearing more on this particular topic from you and your fellow panelists during the event. And I really hope that you have a great day ahead. And now, finally, coming to the end of this particular podcast, I would like to address the audience on our behalf. And if you are looking forward to meet Victor in person and have an insightful discussion, we are waiting for you to join our upcoming conference on information technology on 22nd September 2023, happening in person in New Delhi. So thank you once again, Victor, for your appearance and sharing your thoughts on Kubernetes and this particular topic that we're going to be having during the conference.
Thanks.